Hello, all you beautiful people. Really excited to give this talk. Every time I give this talk, I always kind of take a little scope of the room. So who here has grown mushrooms or is currently growing mushrooms? Okay, 1, 2, cool. Maybe, cool. Okay, good. Okay, well, there you go. We got 4. Awesome. So I'm gonna be totally honest. This talk is going to get into some serious weeds of science. This talk is about using a very specific culturing technique in order to improve your ability to cultivate. So there's a lot of different ways you can cultivate mushrooms, but this is the cabin sequestering technique is the biggest innovation in culturing that has happened in almost the past 100 years. And this all happened, published in December of 2019. And so it came out during COVID. Not a lot of people have, because I've got a background in chemistry, I'm constantly looking for new publications that are being released. Yeah, this is the same talk I did last time. I'm still trying to just push people to just like take it, just learn about it. Try it. It's good for you. And it's even better for your mushrooms. So if, it might be a little heavy for some people. I just want to make sure that I let everybody know that this talk is very science heavy and it might be a little bit more than you're looking for, but I do appreciate you being here and I hope that you can learn something through this. Okay, so my talk's about cabin sequestering. The original publication was a handy method to remove bacterial contamination from fungal cultures by Xiao et al. And I'm super excited to give this presentation to you so you can learn more about this technique. Okay, so why cabin sequestering? The bane of mushroom culturing is contamination. And you have generally 2 different types of contaminants, fungal and bacterial. And then you have 2 different types of contamination sources, endogenous and exogenous. So things that are either contaminant from the environment that are coming into your culture or things that were already growing with your culture, right? And so if you have an endogenous infection, it's very hard to tell that it's infected. And so you'll grow mushrooms and you might have success once or twice, and then all of a sudden you take your agar plate or your liquid culture and you put it in a grain bag or you put it in your substrate, and then all of a sudden it's just mushy. Constant infection. You don't know why. You think it might be the technique, it might be this, it might be that. No, the infection was with your culture from the very beginning, but you just didn't see it. And so this is about trying to overcome all the shortcomings of antibiotics, because antibiotics, for the most part, when you put them in agar, doesn't really work. It works a little bit, but as you'll see later in this presentation, it is not 100% effective. It's not even barely 50% effective. And so a lot of people will also try and use nutrient-deprived media. So by not providing enough food for the contamination to grow, they assume that eventually the mycelia will grow past the contaminant, and then you can select a clean piece of agar, transfer that to a new plate, and outrun your contaminant. But the problem with that is obvious, right? The mushrooms need food, just like the contaminants need food. So when you don't put any nutrition in your agar, you stunt your mushrooms just as much as you stunt everything else. And so there's got to be a better way, and this is exactly that. It's much more efficient, it's much more time effective, and with a few tweaks that I'll be presenting later, you'll be able to see how you can run multiple samples on a single plate. So you can be very resource and time effective too. So before I get into cabin sequestering, I want to kind of go over the previous techniques that have been used throughout history. So the first is the cold pour technique by J.E. Masheshik. And basically what he was doing is he was taking the agar and then waiting for it to cool down to the point right before it solidifies. And while it's still cold, he would pour it into the plate and then take his contaminated fungal sample, put it into the center at the very bottom of the well, and then he would wait until the mycelia had grown far, far away from that centerpiece where the contamination was. So he was encapsulating the contaminant and the culture in the agar while the agar wasn't hot enough to kill the culture, and then waiting for the culture to grow through the agar until it reached far away from that inoculation point. And then from there, he was able to get clean cultures. The problem with that is obvious that, it's very hard to tell when the agar is cold enough, right? It's kind of subjective without having a thermometer. And even if you did have a thermometer, you have a very small window. It is a very, very, very tight window between, okay, it's not that hot and I can stick this in there, and then it's solid, like a rock. And so later on, you can see here, there's almost a 70-year gap between any innovation that's happened. And so now you go to SS Coe, and he developed the flip and scrape technique. So what he would do is he would go and take the contaminated piece, put it on top of the agar, let the contaminated piece grow through the agar, and then he would cut a window in the back of the agar plate if it was a plastic plate, and he would select some agar from the back of the plate, or he would flip the entire plate over, and he would then go and select from the back of that plate by flipping it. So if it was like a glass plate, you can't cut through it. And then later, in 2009, N.J. Kother et al. Went and created this agar sandwich technique that doesn't look quite like this sandwich, but I thought it was really cute, so I wanted to include it. It looks more like this, where you have your contaminated mycelia piece underneath a giant cover slip of agar with another agar plug on the top, thinking that this may contaminate, this may have some small amount of contaminant that might penetrate through, but it's not going to go all the way through to that agar plug. So this plug, in theory, should be clean. And so this was a technique that's been used since 2009, and a lot of people have had great success with it. But the obvious downfall here is that you just need a lot of agar. You need a lot of plates. It becomes, it's just kind of a little bit more complicated than what most people are trying to do. Yes?
Am I correct in understanding that in all three of these techniques, the assumption is that the correct mycelium will grow faster than the bacteria through the agar?
So the question was, with the assumption behind these techniques that the mycelia would outrun the contaminant? Yes and no. So if you're looking at fungal cultures, then it will grow, fungal contaminant should grow slow enough through the agar that you can isolate your culture of interest before the fungal culture and the contaminant fungus ends up ruining it. And then with the bacteria travels with the mycelia over the surface of the plate, which is why a lot of people don't notice endogenous infections. So yeah, if you have a raging infection on your plate, it will show up as a giant blob, and you'll see it. But sometimes that doesn't happen. And that's what you'll see later in this presentation, is that sometimes those infections grow along with the mycelia, and you never actually see them until you put them in a super high nutrient-rich environment. So you take that agar plate, you put it in a bag, you crush it up and you shake it. Well, you've just taken that bacteria and smeared it across the entire bag. And then all of a sudden, the whole bag goes to goop and you don't know what happened. You're like, well, the plate looked clean, right? And so the theory behind this is that the bacteria cannot grow through the agar. The bacteria has no form of locomotion, generally. So some bacteria have a flagella that allows them, kind of like a tail, to wiggle through, to go ahead and wiggle through. But most bacteria don't. And so they depend on you picking it up and putting it there, right? And whether that's with your tool or with your breath or with your hands, or through some other, source of contamination, you have to pick up that bacteria and place it there, or it just hitchhikes a ride with the mycelia and just rides with the mycelia over the top of the plate. But the bacteria doesn't grow through things; it grows on the surface of things, right? I don't know of many instances where a disinfectant is having to disinfect deep inside the surface to kill some sort of bacteria that's in the table instead of on the table, right? And so if it has to, with all of these properties, you're having to grow through the agar. Your culture is having to grow through the agar, and by growing through the agar, you're then creating a separation because the bacteria cannot follow through it. It can go over it, but not through it. The fungal contaminants can, but there is it does slow it down to some degree. Sure. Yes. And for the most part, you're going to have to rely on your experience with that culture and your knowledge and your expertise of knowing what is and what isn't. So you already know what is. You're like, I want this thing to grow. And you have some experience with what that looks like. And then you just kind of make a separation. Anything that doesn't look like this ain't right. And so you just keep running away from the stuff that doesn't look like what you want. And eventually you kind of develop a keen sense of color and texture, right? Because some fungal contaminants, they all may look white, but there's a gradient of white, a gradient of color. Some are more gray, some have maybe a tinge of green, like a hue to it. Some are pure pearly white, and maybe some cultures grow out more of like a tan. And so they all have their own look and feel. Some have very dense mycelia. Some have very wispy, kind of like cobweb mold. It's very stringy, wispy mycelia. And so depending upon the look of the mycelia and also the color of that mycelia and your knowledge of the culture that you're wanting to isolate, it makes it a little bit easier to kind of gauge what and how what you're going for and how to run away from the stuff that's not working. Yeah, hope that answer your? Okay, perfect. Okay, so the operational procedure for this paper was pretty simple. They took sterile media, they then burrowed a hole, aka the cabin. They then placed the contaminated sample in the middle of the hole. They then take another piece of clean agar that's cut in the shape of a roof, usually like a square wedge, and they would place that over the cabin that they had made. So the cabin had walls and a roof. That's where the idea of the cabin came from. And then after about 7 days, the culture would grow through the agar to the edges. A sample was then taken and put on to a new plate, and then DNA extraction was done a few days later in order to go and amplify the DNA of the contaminated culture to see whether it was present or not present. Hey, can you walk around? I'm so sorry. And do you need anything else from this corner? Is there anything else I can get you? Is there anything else you need in this corner? Is there anything else you need in this corner? Okay, thank you so much. Sorry. No worries. Okay. And so what they would do with this gel electrophoresis is be able to see whether the DNA was amplified or it was not amplified. And that's how they were able to tell whether the technique worked or not. And so with PCR, you run hundreds of cycles sometimes in order to amplify the DNA. So if there's any DNA present at all, it's going to make a ton of it by the end of the process. And so usually through PCR amplification, you can have pretty good resolution as to whether something was present or not. The only way you could get better resolution is through whole genome sequencing. But that's very expensive and very time-consuming. And so gel electrophoresis is simple, low-hanging fruit and is easy for most labs to do and run in mass and not be spending an entire life fortune on doing it. So 4 strains of Myriaceae were tested, which is a very common fungi. And then on top of that, 4 different plant pathogenic fungi were also used. So to say, okay, well, it worked for one fungal strain, but does it work for everything, right? So that's what they were answering here. And what they did is they spiked the cultures with E. coli and Agrobacterium tumefaciens, which are very, very common bacteria that you would find in soil or water, other surfaces. Very, very common contaminant. And what they did is they did a treatment group of cabin sequestering without antibiotics, and then a group with antibiotics, and then a group with antibiotics alone, and then a group with subculturing, what I like to call optical isolation, running away from contamination, saying, well, that doesn't look contaminated, I'm going to put that to the next step. And the antibiotics used were streptomycin sulfate and potassium penicillin, which are used for most gram-negative bacteria. and are very, very, very common antibiotics that are used specifically in fungal culturing to remove bacterial contaminations. And they had created an evaluation equation, which was the efficiency of removal of contamination was equal to the number of progeny cultures without bacteria divided by the total number of progeny cultures times 100. So if you had 10 cultures and all 10 of them you were able to remove the contamination, then you would have 10 divided by 10, which is 1 times 100% efficiency, right? So that was essentially how they were able to make math out of all of this. Okay, so the DNA, after they let it sit in complete media for 3 days, they would do an extraction with using the CTAB method, cetyl trimethyl ammonium bromide. Not important to know exactly what that is. It's just a method used for extracting DNA from fungal cultures and from bacterial, from all sorts of stuff. And then they had primers made that were specific for amplifying the E. coli and the tumefaciens, just to make sure that they were amplifying it if it was present. And pure cultures were used as positive controls. Distilled water was used as a negative control, and 30 progeny cultures were produced for each sample and tested in triplicate, just to make sure. And so here are the results. For the MRIZA, cabin sequestering without antibiotics was 97% effective at removing those bacterial contaminations from 1 round of using this technique. Cabin sequestering with antibiotics was 95% effective. The publication made it very clear that the difference between these two numbers was not statistically relevant. They are practically the same. Antibiotic treatment alone was only 15% effective after 2 rounds of culturing, 2 rounds of running away from contamination. It was only 15% effective. So, just slightly more than 1 out of 10 plates passed the test after doing this twice. And if you're just using optical isolation, less than 5% effective after 2 rounds of culturing. So if you're just looking at it and hoping that it's not contaminated, there's a greater than 95% chance that it is. And you just don't know it. So what was interesting is that the technique improved the morphology, the look of the mycelia in the cultures, and it produced stronger, better, healthier growth. And what was thought was because the mycelia had to grow through the agar, it would separate the weaker genetics from the stronger genetics. So the weak stuff would take longer to grow through the agar than the stronger genetics, because most of fungal colonies are multiple genetics mixed in. They're not monoclonal, one gene. They have multiple genetics, and those genetics all share the nutrients. And the weaker genetics might funnel nutrients to the stronger genetics so they can push out progeny, mushrooms, in order to create more in the future, more opportunity for growth in the future. But through using this technique, you're able to weed out a lot of the weaker stuff and get stronger genetics. At least that's what they found, and that's what I found in using this technique for over 2 years. And what was great is that not only did it work for MRIZA, they had similar results for the other 4 fungal cultures that they had, species that they had tested. So here's a picture of the MRIZA strains. So T1, cabin sequestering without antibiotics. T2 is cabin sequestering with antibiotics. T3 is your antibiotics alone. T4 is your optical isolation. And you can see between T1 and T2, in pretty much every case, there's not a giant difference. Maybe the T1 looks slightly better on some, maybe T2 looks slightly better on some, but for the most part, they're pretty much the same. You can tell that the technique is very effective, especially when compared to antibiotics alone. You can see that there's a color difference. There's a difference in how quickly it grows. It doesn't look the same. And if you're just hoping and praying that you're running away from contamination, you can clearly see it's not working. And in some cases, you can even still see the contaminant still on the plate. There it is, your giant glute blob. And the same thing with your other cultures. Same exact thing. T1 and T2 looked pretty much the same. T3 definitely looked worse than T1 and T2, and T4 was definitely the worst of all, and still often looked as though it was still contaminated. And so here you can see the results from the gel electrophoresis after PCR amplification. And you can see with T1 and T2, there's no bar. So this E. coli is the standard. And so this is how you can tell whether it was present or not after amplification. And then the CK is your double distilled water, your negative. So this should always be clear. This should always be the same. And then you have these four right here. And T1, T2, for almost every single sample, you see nothing. And then T3, you see a presence. T4, you see a presence. So if you're just using antibiotics on your plate, still contaminated. If you're just running away from contamination, it's definitely contaminated. There's a greater than 95% chance, I can almost guarantee you it's still contaminated. So, yeah, and this is the other, my clicker didn't click, my bad. So this is the other, the Gliosporidia, the Selenii, the Rodinia, and the Graminearium. And so you can still see the same thing. T1 and T2, very similar. T3, fall off. T4, definitely does not look good. And so with me in exploring this technique, I found that it works on a whole bunch of different species of mushrooms. I've used it to clean up wild cultures of Ganoderma, your reishi mushrooms, Letiporus, your chicken of the woods, your Pleurotus, your oyster mushrooms, your Erinaceans, your lion's manes. And I found that different mushrooms prefer getting isolations from different parts of the mushroom. For me, I found that Ganoderma, I get really good cultures from the pores. I've tried to take inner meat selections like you would with most mushrooms and not found a lot of success, but the pores tend to push out really good, strong, healthy mycelia. For chicken of the woods, I've found that the pores often contaminate, but if I go to the center near the base of the mushroom, I can get cultures started from there pretty easily. For oyster mushrooms, you can pretty much, wherever you can pull off a piece of mycelia, it'll grow. And then for lion's mane, you always want to try and dig as deep into the center of that mushroom as possible. Because of how porous lion's mane is, it's just like a giant ball that absorbs, it's like a sponge. And so, if there's any sort of moisture, rain, water, it's going to absorb all of that. And guess what follows water? Bacteria. Guess where the bacteria is? On the outside, in the air, in the water, on the ground. And if it's on the mushroom and the water pushes it into the mushroom, then now it's in the mushroom too. So, especially with lion's mane, I try to dig as deep as I possibly can, getting to the very, very, very center of the mushroom where it's probably the most sterile, and I have the greatest chance of success of getting some growth going that I can then put through this technique. Question?
Yeah, in the context of your sampling locations for Ganoderma,
Sure.
the reading that I've done has suggested that particularly in the context of cloning, one will avoid places that are spore-bearing surfaces.
Sure.
You might end up with germination instead of clone.
Correct.
Relevant for this conversation?
Yeah, and that's totally fine, and I completely agree. If you're cloning, you definitely don't want to do it from the pores or from the gills or from anything like that. The question was, is it, if you're trying to clone mushrooms, would it be an issue if you cloned from the gills or pores where the spores come out? And the answer is yes. If you are trying to clone something and get an exact replica, then yes, that definitely will happen. But at least for reishi mushroom, I've found that being able to get multiple layers of progeny and then using the technique in order to filter out what the good stuff is versus the not good stuff definitely helps me to get a good lineup of monoclonal cultures that I can then run together to find what's really going to be the slam dunk. Especially when you are growing something from the wild, it's trained to grow on a tree. It's not trained to grow in a bag. Not that it can't grow in the bag, but it's not trained to do that, right? It's used to getting a very specific type of nutrition provided by the environment that it's growing in. But as soon as you take it out of the wild and you put it in your lab, you're now God. Everything it is you provide. If it doesn't get water, it's because you didn't give it. If it doesn't get food, it's because you didn't provide it, right? And so you're having to train this thing that's used to being in one space to live in another space. It's like taking someone who's a carnivore and training them to be a vegan. On day one, it's not going to look good, But after enough time of doing it, it's possible, right? And so it's about, for me, at least when I'm getting stuff from the wild, I'll generally try and get maybe a clone, until I can get to a place where I can collect clean spores or get a spore sample. And then from there, the progeny from that mushroom, I can collect a bunch of different phenotypes, and out of those phenotypes, one of them is going to be a slam dunk, and I mean a slam dunk. But usually right out the gate, a clone straight out the woods doesn't really perform exceedingly well in a laboratory setting. I hope that maybe answers the question a little bit. And so what's great about this technique is a lot of people, when they're running away from contamination, it may take them, in their minds, 5, 7, 10, 20 plates. It can be a long time. If the sample was very heavily contaminated, you might be running for a while. And even then, you're selecting until you stop seeing the booger on your plate. But I've already told you there's a 97% chance that it's still there, and you just don't see it, right? So even if you're running away, you're not actually getting rid of it. You're just masking it until it gets to rear its ugly head later down the line. And so this technique is not only effective, but in 1 to 2 rounds, you can get completely clean cultures. So if you want to be super, super anal and you want to know for sure there's absolutely no chance there's bacteria, you do 2 rounds of this technique that's 97% effective, and you get a dangerously close number to 100% effective at removing all the stuff that you don't want. So, and what's great about this technique too is I can run 4 samples on a single plate. Oftentimes, you can't multiplex like that. You have to do 1 sample per plate. But with this, especially using this technique, I can run up to 5. So you have your 4 corners and then even 1 in the middle. So depending upon what you're trying to do and how you're trying to do it. And I've definitely found that it's generating stronger cultures. It's much more time and resource efficient. I'm not having to use 5, 6, 7, 10, 20 plates in order to clean up a culture and to know for a fact that it is wholly clean. And so my general workthrough of my workflow when I'm collecting something from outside in the woods, and I'm running it through this whole technique, is I will go and collect my sample, and I'll place it on a clean auger plate, and I will wait for it to kind of fluff up and to start to grow. I have, in the past, tried putting the sample directly into a cabin, but what I've found is that the process of going from fruiting body back to mycelia requires a lot of oxygen. Right? Mushrooms are not plants. They require oxygen in order to breathe. They do not produce their own food. They have to digest the environment around it, right? So if you put the culture directly, like a little sample directly into that cabin, what happens is that cabin, it eats up all the oxygen in the first day. And then after that, it's just sitting in this high CO2 environment, and it takes a really, really long time to grow out of it. Very, very, very long time. So, 2, 3, 4 weeks. So what I found is that essentially, quote unquote, germinating it, getting it to start producing that secondary mycelia on a plate first, and then putting it into the cabin gets me superior results, and I'm able to basically cut my time in half. So I start by generating some mycelia from my sample, and then I take that piece of mycelia, and I'll go ahead and put it into my first round of cabins. And I will either take this and move to the next step or repeat this a second time. But after doing it maybe twice, I then take selections from around the outsides of these cabins, and I will put them on another plate. And then from there, I will wait about 4 to 7 days and then check how quickly it's growing. And that gives me an easy way to see what is growing the fastest. And so in this example, these 3 kind of did the same, and this one clearly did more than the rest. But even this one is not a monoclonal genetic. It's not monoclonal. There's still subspecies even within this, even after 2 rounds of cabin sequestering. So I'll take this piece and then put it on multiple plates, and I'll notice that one of those plates outgrows all the others. And this is highly likely monoclonal, as opposed to here, here, or here. And so that's how I'm able to generate clean, healthy cultures using this technique without any sort of antibiotics, without any sort of fanciness. And I can do this entire process in as few as 2 plates, as many as 5. I mean, as many as you really want. But It's pretty efficient. It's pretty effective, and within about 2 to as much as 6 weeks. That's the upper end of the limit. I can go from the woods to a grow bag and be able to start commercially producing a mushroom that was found outside in nature. And 2 to 6 weeks may not seem like a short amount of time, but when you're considering if you're trying to run away from contamination the old-fashioned way by just picking a clean piece, putting it on a plate, picking a clean piece, putting it on a plate, every time you do that transfer, you're waiting 7 days. If you have 5 plates, that's 5 weeks. If you have 10 plates, that's 10 weeks, right? So the numbers keep going up. The more plates you're trying to transfer from, and guess what? Yeah, there's still a 97% chance it's still contaminated. Yep. Yeah, so the question was, is putting it on the first auger plate a form of training the mycelia to grow in the environment that you're creating in the lab? And that's exactly correct. Yeah, it's a part of the process because it's never seen auger. Auger doesn't exist in a tree, right? All these other nutrients you put in the auger, dextrose being the monomer of cellulose, that's what the mushroom is going into the tree, taking the cellulose, breaking it down into dextrose. So if you're using dextrose as a sugar, as a nutrient, it's definitely seen that before, but it probably hasn't seen peptone or yeast extract or whatever other, light malt extract. There ain't no malt in the tree. So, you're essentially having to train it to recognize, hey, you're in a new environment. There's new food here. It'd be like transplanting someone from one country and moving them to the other side of the world and giving them food that they have never eaten before, right? You would have to start by slowly introducing things and then changing the gut flora and then being able to ramp up to have a full meal diet. It's why a lot of people, when they go traveling and they eat food from other countries, they have a Montezuma's Revenge or what have you, whatever. So either way, did that answer your question? Cheers. And so here I've got a little video of me, and I'm going to go ahead and pass out these auger plates so people can see them. And I've got a little video of me kind of doing the technique. We'll see if it works. Maybe not. So here I'm just cleaning everything because that's really important. And then I'm preparing all of my plates. And now I'm sterilizing the tool in order to make sure that it's not contaminated. So you heat it up really hot, and it should definitely sizzle while it's on the plate. And so in making cabin sequestering plates, you need 2 plates. You need 1 plate to be your cover slip plate. And then you have the other plate that's your cabin plate. And for this example, I'm just doing 1. To make it really easy for people to see that it's super, super simple. And so here I'm just cutting the culture, being very careful to pick it up, and then place it directly into the center of the cabin without smearing it around the edges, without taking my tool and touching a bunch of stuff. Because you got to remember, if your tool is clean and then you put it in something that is dirty, now your tool is dirty. Every place you put that tool, it's going to carry that dirt with it. So you don't want to move it around and wave it like a wand. You want it A to B, and that's it. And then once you place the cover slip, you go ahead and seal it up, and don't forget to label it. Don't forget to label it. It's almost like I've done that before. Nope. Okay. There might be another. Is there another one? Okay. No. I'm done with you. Paul. Be gone. Okay. Let me see. I think this is my second video. There should be 2. Okay. So we're going to go through this, but this is with the multiplexing. That's what I call it. So with this, instead of making 1 hole, we're going to make 4 holes. And what's great is that you can run them all on the same plate. And so it makes it really easy that if you have a sample that you can run multiple samples on one plate, which saves you a lot of time and energy. So instead of having to instead of having to have 5 auger plates for this technique, where you would have, 4 singles and 1 plate for cover slips, it makes it really incredibly easy to just run them all on the same plate. So, which saves you 3 extra auger plates that you don't need to make. And so one thing to note is, as I'm placing these cover slips, I'm placing them over it. Notice that I'm not sliding the cover slip around. It's going immediately directly over the hole, and then I'm pressing on it gently to remove air bubbles. But you don't want to slide that cover slip around, because if there's any bacteria around the edge of that cover slip, and you're going to smear it all around that cabin, and then the cabin's not going to work. So really, the technique is very simple, but the fine tuning is in how well you can take your sample, put it in the hole, and then take that cover slip and cover it without having to touch it or move it any more than what's absolutely necessary. Yes, question? Sure. So the question was, why didn't I re-sterilize the tool after collecting each individual sample? So in some cases, I actually do that. In this particular case, this culture that I started with produced really clean mycelia. I didn't see a whole bunch of goop. This was a Laetiporus cincinnatus that I collected up in Roswell Mill Park. And the samples I collected produced beautiful, healthy mycelia. There was no fungal contamination on the plate, nor did I see a bacterial contamination on the plate. So I felt it safe enough to be able to resample using the tool multiple times from the same plate. You can see where the samples that I placed onto the plate were, and then you can see that I collected in between them. So I did not collect too close to the original sample, just in case there was a contaminant there. I collected just a little bit away from it to help give myself a little bit of removal from that space. But if I am dealing with a very heavily contaminated plate, like it's nothing but soup and green, but there's a couple patches of white that I'm trying to isolate, then I will go ahead and sterilize in between each touching of the plate, because if you touch it, the second you touch it, it's contaminated, right? And so, maybe you can get one clean piece, but the second you go and reach for another piece, the tool's already dirty, you're contaminating the next sample you're touching. And so with the cover slips, I'm very careful not to touch the samples at all. Like I will lay like a corner down, and then I kind of just drop it, and I move the tool out the way. So the tool never actually touches the mycelia. And so that's why, at least when I'm using the tweezers, I'm not re-sterilizing that constantly, because I've just gotten to a point where I can do the technique without risking contamination for that specific tool. But when using my little cutting tool and placing the samples into the cabins, I will sometimes, especially if the plate is heavily contaminated, I will definitely sterilize in between each use. And even when I am going from this first cabin plate to the next cabin plate, I will sometimes, especially if I still see contamination, like you'll see contaminants bubbling up around the edges of the cabin. You might see some bacteria, you might see some yeast. If you don't see it, you'll definitely smell it. You might see some other fungal culture growing around it. And at that point, especially if like these 3 are clean and this one's dirty, but I really want to collect something from here, then I will definitely sterilize before touching that and after touching that. I won't risk any of the other cultures. And if one of them's contaminated, I assume they're all contaminated. And I treat them with that same level of stringency and technique. I try to be very on it to dramatically improve my chances. This is all a lottery, right? Playing with mushrooms is different than plants in the way that with plants, you can really see what's happening. You can watch it form cotyledon leaves. You can watch it grow into a plant. With mushrooms, you can't really see what's happening until it's already pretty far down in the process. And so you gotta just use probability to your to your advantage and to increase the probability of things working in your favor as much as you possibly can. And that's why this technique is so important, is because if you're just looking at it, I hope I've established is not good enough. It's 97% going to fail on you. And if it doesn't fail immediately, it will fail at some point in the future. It's just a matter of time. And if you're trying to be fancy and you got on some website or, whatever, the Shroomery or something, and all these people are raging about, oh, I've got all these antibiotics on my plate, trying to be a cool kid. That's great too, but that's already 15% effective, and that was after doing it twice. So, you've got a 85% chance it's still contaminated, and that's after doing the whole thing 2 times. So, it's like, why waste your time and your money to try and work with something that isn't working with you and is working against you? It's like showing up to a casino and playing the game that you only have a 5% chance of winning. It's like you're definitely not going to hit the lottery there. I'd rather take something that at least gives me 50-50 or better. And this technique is giving you 97%. So if, when performed correctly, is giving you a 97% lead. So let's see. We'll go to the next one. Oh. Uh-oh. There we go. So in conclusion, there's no difference between the cabin sequestering technique with antibiotics or without antibiotics. So why use antibiotics? Why waste your money and your time and go through all the loopholes and the rigmarole of having to get a whole bunch of antibiotics and have people questioning why you're getting them and all that other stuff? Why go through that if you don't have to, right? And why stick to what everybody else has been doing when you can be the cool kid and do something no one's doing? Something that's also going to be, a lot more effective than what they're doing. And they're going to sit there and brag about the mushrooms they grow until they see yours. And then they're going to be like, oh, okay, this is how you really cultivate. I've been sleeping on it. So the technique is efficient. It's got a quick turnaround. It's very simple to perform. All you need is 2 auger plates. And honestly, what's very interesting is I've played with this technique enough that I am able to perform it with 1 auger plate. So if you take an auger plate and you split it up into 4s, like I was showing you in the video, if you go to the spaces in between those pieces, you can cut out a triangle-shaped wedge. And so you can do a 4-cabin plate with 1 auger plate. You can cut the cover slips from the negative space between each sample. And you would just do that before you place your sample in there. And so you can even do all of that with 1 plate if you really, really, really wanted. And I've done that many, many, many times. But for me, I like getting nice big roofs, cover slips to cover my cabins, because it tends to just make sure that it works better. But both work very effectively. I haven't really had any issues. And it has definitely taken my game to a whole nother level, especially when I love when I give other people my cultures and they start growing mushrooms from the stuff that I have, and they're like, oh my God, what's going on here? This is a whole new world for me. And it's like, yeah, well, you should try this technique on what you've got, and it'll get you right the same way it's gotten me right. So thank you very much for your time. I really appreciate you all being here. I'd like to give my acknowledgments to my family at the CDC, everybody here at Wild Heaven, and to all of you. Because if you weren't here, why the hell would I stand here? So, I'm very, very, very grateful, and especially to the original authors for coming up with this technique. I feel very lucky that I found it as early as I did, and I'm going to keep preaching it and try to get more people doing it. Until then, be prepared. If you have any questions, I might not know the answers, but I'll try. Thank you so much, y'all. Cheers. Questions? Yep. I can go back a slide. The substrates. Do substrates have to be stored at a specific temperature? The cabins? The cabins do not have to be stored at a specific temperature. You would treat it like you would any other culture. So, if you want it to grow quickly, keep it out at room temperature. I generally don't recommend people heating plates because adding heat is chemistry, right? You're adding, as soon as you add heat, you're adding energy to a system. When you add energy to a system, anything can receive that energy, not just what you want. Everything can. So I usually just keep it out at room temperature. If it's 70 degrees in the house, it's 70. If it's 75, it's 75. If it's 68, it's 68. I definitely don't put them in the fridge to grow the cabin because then that completely shuts down their system. Puts them in hibernation mode. Mushrooms are wild beings. They live outdoors. They're used to the wind, the rain, the hail, the sun, the heat, the cold. So, they've got a life cycle for the whole thing. So I generally will keep them out and about until I am done with them. And then when I'm done with them, I can then put them in the fridge. I do recommend, though, that if you are going to store them in the fridge, I would make your agar plates 25 milliliters as opposed to 20 milliliters or less, because the 25 mil plates tend to last longer in the fridge. You will get a solid 6 months out of it and potentially up to a full year before that plate dries out and disintegrates. So something I learned while I was at CDC, and it's something I've carried with me ever since. And it doesn't sound like that 5 milliliters makes a difference, but it sure does. So you really do get some extra time out of it. And plus, when you're breaking it down and putting it in your bags, it's just a little bit of extra nutrition, a little bit of extra culture. It tends to just work a little bit better for me. So that's the reason why I do that. Any other questions? Yes?
Yeah, I got a bunch.
Okay, yeah, I'm here for it. Let's do it.
I'm really interested in the resampling location that you're choosing.
Yeah, sure.
With the idea being that we want to grow mycelium through the agar to
Yep.
leave the bacteria behind.
Correct.
If we're pulling from the edges and not from the roof of the cabin,
Sure.
I've seen shrimp lift the lid of a monotone. Is the
Sure.
mycelium not just lifting the lid of the cabin and coming out that way?
No, not generally. No, because it's all mycelia at that point. It's not fruiting on the plate, and when you put the selection inside of the cabin, you're making a high CO2 environment. So you're not inducing any sort of pinning or fruiting state to the mushroom. So it's staying in secondary mycelia mode, and so it's really just trying to. It's like, oh, I'm trapped. How do I grow? Like when a culture is in leaf litter, it's going to keep growing until it hits air. And that's essentially the same type of thought process you're doing here. By putting it in that cabin, you're forcing it to say, okay, now I've got to grow through this material. And so when you place the roof, and the roof is larger than the hole, so there's that overlap of the roof with these, around the edge. And if you press out all the air bubbles, and it has complete contact, then it still has to grow through that auger. And so it's not like it's somehow slipping in between. It still has to grow through. But I will sometimes also isolate samples from the very top of the roof itself. So I go for what looks good. If I like the way the roof looks, then I'll select from the roof, but making sure that I do not penetrate into the cabin. I will just go just a millimeter deep or less, just to scrape off the mycelia on the top and put that on another plate. Or if I like what's growing on the edges of the cabin, then I will select from the edges, but I try not to select too close to the edges of the cabin roof. I'll try and go like a couple millimeters at the closest away, just in case there might have been some contaminant that was smeared around. And if you're selecting just from that edge, there might still be something there. And really, all that boils down to the technique that you're using and how you're performing the technique. So, sometimes I get great luck and I do it perfectly and I don't have any issues. And other times, man, it's not pretty, and that's okay. We're all learning. So, can't be perfect all the time.
When you're placing your sample in the cabin, your goal is to have none of the sample touching the edges of the cabin, but yes, in contact with the roof?
So the question is that when you're placing your sample in the cabin, can it touch the edges of the cabin and can it touch the roof? The short answer is yes, it can. The long answer is that if it's removed completely to some degree, it's not so far, because let's say you carve out a giant hole in the middle of the plate and you place a tiny little sample in the middle, nothing's going to happen. But if the roof is touching it, then you at least got some chance. But let's say it's so small it doesn't even touch the roof, right? Like the selection isn't big enough, and then it can't, it can puff up and try and reach for the stars, and maybe it might touch something it can keep growing through. But what I like to do is I make it so that it's, if you make it the same size, what happens, and this is going to get a little technical, but the air gap on the bottom of the plate, as you are putting that plug, your sample in the hole, if it's the exact same size, the air that you're trapping has to escape. And so it's going to escape from around the edges of that sample. If you have bacteria on that sample, as you are squishing it into that hole, you are taking that bacteria and pushing it all the way to the very top. And so when you put that roof over the top of it, it's going to just end up being bacteria soup. So I like to have at least like a couple millimeters of space. It can touch to some degree, and most oftentimes I will have it touching at least one wall. That way it has some contact with something. But generally, it will fluff up, and as it fluffs up, it can start reaching. It has a reach of, let's say, 2 to 3 millimeters, and that is enough reach for it to be able to touch the next surface that's going to be able to provide nutrition so that it can continue growing.
Great. Size of roof overlap.
Size of roof, what's the best size roof overlap? So it's up to your discretion. You can go as big as you want or as small as you want. I would say that bigger tends to be better, but also bigger means that it's going to take longer to grow through. So, but time would be the only function in that essence, except for if it's too small. If it's too small, the chances, your probability of carrying that contamination forward is significantly higher. And so, there is a appropriate roof to size ratio. What I like to do and what they kind of recommended is you have at least a 0.5 centimeter overlap from the edge of the cabin to the edge of the roof. So you have maybe about yay space on all sides. And that's about enough of an overlap that you can avoid most of the issues. If you put a giant roof on it, the only thing that you'll see it coming out the top before it ever comes out the sides. But what does come out is almost guaranteed to be pretty darn clean, because it had to grow through, if you put like a 2-inch ledge on it, then it has to grow through 2 inches of material in order for it to reach that other side. But that may take 30 days as opposed to 7 to 10. So, that's where you kind of have to just play around with it. I would go bigger rather than smaller, but it's effective either way. It is a function of time at that point.
Okay, cool. Last one.
Sure.
Once we have performed the technique correctly, we have
Sure.
the basic assumption, assuming we did it correctly, that
Sure.
we are only worried about fungal contaminants at this point. We have
Sure.
successfully isolated the bacteria. Does that change, or are there any optimal colors of homemade agar you would use, given that you are no longer looking visually to see bacteria, exclusively trying to identify fungal contaminants?
Yeah, I mean, that one is pretty hard. If you have issues with fungal contaminants, what I highly recommend is you watch that plate like a hawk. You watch it every day. You treat it like it's your baby. And you just keep an eye on it. Because, Aspergillus niger, Trichoderma versicolor, very, very, very common contaminants in cultures. They grow very quickly. Cobweb mold, very fast, right? And so some of those things, like cobweb might be, or other types that can triple their size within a day, maybe a little, this technique may not be effective for those specific things. But then again, your sample's pretty much dead if it's infected with that anyway. But, at least for Aspergillus and Trichoderma, generally it takes about the same amount of time to peek through the cabin that your culture does. But what ends up happening is you will see zone lines, distinct separation of the two types of mycelia because they are not compatible with each other. And if you know, this going back to the very, very, very beginning of the talk, if you know at least what you're looking for, then you know that what you don't want. And from there, it makes it a little bit easier to be like, okay, I've got two different types of mycelia. This one's pearly white, like my original culture. This one is an off-white, almost a gray. And this one has nice fluffy mycelia. This one has super dense mycelia. And as it's peeking through that auger, you can look at it and say, okay, there's a very high likelihood that this is probably a contamination, a fungal contamination. This one is probably my culture of interest. And anytime I notice that there's a contamination on my cabin plate, I always do it again. I always recabin. But I've never had to do the cabin more than twice. I've done it more than twice, but not seeing any more effectiveness in the results. It tends to be pretty much the same. Fungal contaminants do not cohabitate like yeast or bacteria contaminations can. And yeah, yeast is a fungi, but it's different. So it's more fluid in the way that it interacts with its environment. And so you can smear that around just like you can bacteria and get similar results, at least as far as contaminants are concerned. But when dealing with Ascomyces and most Basidiomycetes that you're trying to run away from, you can usually tell the difference in the morphology of the mycelia and then be able to select away from it. And as long as it hasn't spored yet, which is why I encourage you to treat it like it's your child and you just watch it like a hawk, because before it turns a color, it's all mycelia, and you can run away from it. The second it turns a color, you've got problems. Not that you can't fix them, but it's just going to take more time. So I hope that answers your question. Yeah, no worries. That's what I'm here for. Any other questions? Anybody else? Anybody else? Okay. Much love, everybody. Sorry, what? Yeah, what's great about this festival is that we live stream it, and then we take the live streams and we chop them up into YouTube videos just so that you have access to this knowledge whenever you want to. And we do that for y'all because we love all of you so much. Do I put my journey of experimentation online? No, I'm one of those guys that likes to hide in my little basement and just do the thing. This is my outreach. I may seem like a really strong extrovert, but inside, I am deeply introverted. I like to be at home on my couch with my wife and my dogs and my cat and occasionally my snakes. And I hang out. But this is my outreach to being in the public and to talking with people and sharing, all this amazing knowledge that's coming around. And this technique, while it seems so simple, and it is, it's been almost 100 years since someone's come up with anything better. 2019 is brand spanking new. So, the last major innovation was, the first one was in 1937. Right? So it's been a long time since anything like really new has come around. And so as simple as this technique is, and that's why I encourage it, and I put up the DOIs. If you have access to Sci-Hub, if you've ever heard of Sci-Hub, Google what Sci-Hub is, and Sci-Hub can get you a lot of publications that you would have to pay for free. And so if you plug this information into Sci-Hub, you can have the original article for free. And you can go and learn all of this information directly from the scientist's mouth yourself. Yep. So, anything else? Thank you so much, everybody, for your time. I hope you had thank you so much again. I really hoped you enjoyed this festival. It's nothing but love, and we appreciate y'all so much. We wouldn't be here if it wasn't for you. So, much love. Keep cultivating. Thank you. And this concludes the festival. Amen. We did it.